Okay, so let's look at some examples. We want to use set notation to describe the green shaded regions in each Venn diagram. What I'd like you to do is pause the video and try this on your own first. Get your own answers and then compare them to mine. Now, there are multiple ways to describe sets. For example, we saw a few videos ago multiple ways to describe the complement of B with respect to A, for example. So if your notation doesn't look exactly like mine, you should ask if your notation is still correct. Okay, so go ahead and pause and then come back and see what I do. All right, so hopefully you've tried these on your own first. The first thing I want to do is sort of think about what each of these shaded regions are. So if I just look at this yellow piece, that's exactly what we describe to be the complement of B with respect to A, or A without B. And similarly, over here on this side, this was B without A. Now, if I want both of those regions, I've got both of those regions shaded, I'm going to use the union. So I want the things in the complement of B with respect to A over here, or in the complement of A with respect to B over there. Okay, what about B? So here, again, if I think about each of these regions separately, since they're disjoint, this first region is just the overlap between A and B. That's what we call A intersect B. Similarly, this region over here is just the overlap between B and C. Those are things that are in B and in C, so that's B intersect C. And I want things that are in either this yellow region or this yellow region. So I'm going to take each of those sets and union them together. So this is the set A intersect B unioned with the set B intersect C. Okay, what's happening in C? Well, down here, what I've shaded is the part of A that doesn't contain C nor B, right? So I want things in A that aren't in C or B. Well, what that sounds to me is I want things in A that aren't in B union C. So this is the complement of B union C with respect to A. You might also have written this as A intersect with B complement and C complement. We don't use that notation. Let me write this with the bars. Okay. All right. D is a little bit trickier, and there are lots of approaches to this one. Let me just tell you what I thought of doing. So if I were to shade all of this here, here's all of A, and here's all of C. So now this yellow region is A union C. But I don't want this little white bit. So what if I remove B? Okay. So I'm going to remove B. And I do that by taking the set difference. So A union C, set difference with B. Now that's almost what I have, but I need this middle region. And this middle region is the part that's common to all three sets. So what I want to do is union this yellow with A intersect B intersect C. All right. That one's a little more involved, but you can do it. Just think of it one step at a time. Okay, so we can use Venn diagrams to help us solve word problems. So this first example is just getting us used to describing the sets. So I'm going to let M be the set of all students taking math and E the set of all students taking English. And I want to describe what's happening in the regions A, B, C, and D. Okay, so I'm thinking of A as this region here. So in words, what is that? That's the set of students who are taking math, but not English, right? Because we've removed the overlap over here with English. In set notation, that is the set difference of M and E. What about B? Well, B is the overlap between M and E. These are students taking both math and English. Set notation is M intersect E. C is just the mirror image of what A was. Right now I have students who are taking English but not math. And so that's the complement of math with respect to E, or the set difference E of E with M. And finally, D is the set of things in my universe that is outside M and E. So these are students who are taking neither math nor English. Our set notation here, is going to be the set of students in English union with M complement, right? The set of students not in English or math. Okay. Let's try putting this all together in a single word problem. So I've taken a survey of students, and I'll let you read through the numbers, but I know how many students took the different courses. So this problem is hard to answer without a Venn diagram. So the first thing I want to do is fill out my Venn diagram and then use those numbers to answer the questions on the left. Okay, so I want to label my circles in my Venn diagram. I'm looking at physics, biology, and math. And what we want to do is sort of work from the inside out. So I'm going to start from the most overlap. 5 students took all 3 subjects. All 3 subjects is where all 3 circles overlap, and there are 5 students in that overlap. Now I'm going to move out a layer to where 2 subjects intersect. So physics and biology. 6 students took physics and biology. The overlap with physics and biology is all of this, but I've already included 5 of those students in the overlap with math too. So if I need 6 altogether, I'm going to have 1 student up here that didn't take math but still took physics and biology. All right, we're going to do the same thing for the other 2 sets of intersections. So 8 took biology and math. So I'm looking over here. I've already got 5, so I need 3 more to get to 8. And 10 took physics and math. I've already got 5, so I need 5 more to get to 10. Okay, now I can move out another layer to just the subjects themselves. So 48 students took mathematics. 10 of those students are here, plus 3. So that's 13 students already accounted for in math. So I need to take 48 minus 13, which is 35, and that tells me how many students took just math and not physics or biology. All right, similarly, 45 students took biology, so I'm going to take 45 minus the sum of the 3 regions that are already labeled. So I've got 6 plus 3 is 9. So 45 minus 9 is going to give me 36 students over here. And similarly, I'm going to take 25 minus 11 to get 14 students over here. Now, there were 110 students surveyed, and my circles may not account for all 110 students because there are possibly students who didn't take physics, biology, or math. So what I want to do is add up the numbers in my circles to figure out how many students go outside. So I'm going to do some scratch work over here. I have 14 plus 1 plus 36 plus 5 plus 5 plus 3 plus 35, and that's going to give me 99 total students accounted for in the circles. And so the total students outside the circles is going to be 110 minus 99, or 11. So there are 11 students outside here. All right, let's use our diagram to answer the questions. How many students took biology but neither physics nor mathematics? So I'm looking here in my biology circle, and I want just the students outside of the physics or the math. So 36 students took biology but neither physics nor math. How many took physics, biology, or mathematics? That's the union of the 3 sets, and to get those students, I would add up all of the numbers in my circle, which I've already done over here. So 99 students took physics, biology, or mathematics. And now how many did not take any of the 3 subjects? Those are the students outside of the circles. So 11 students didn't take any of the 3 subjects. You can see how these questions would have been a lot harder without our Venn diagram. It's hard just to look at these numbers. You want to be careful that you don't just add the number of students here, because that's going to double count students, right? Some of those 45 that took biology also are in physics or in math. So you really want to get comfortable putting these numbers in your Venn diagrams.